just a comparison test. So we're going to be given some series A, and we know it will converge because it looks like some other series B, and we know B converges like we had the p-series test before, or we know it's a geometric series where the ratio is less than 1. So what we're going to do is compare them, and we have our rules. So we're going to start with our first one, which is convergent. So if we can just show that our A sub n is less than our B sub n, then if our B sub n is convergent, so is the one that we're trying to show is convergent. So it's like this. I've got them written out. We have some B sub n here, and you can see it's bigger than A. So like if we look at each general term, this would be like, say here it's 4 and here it's 3. It's smaller. You can see the red dot is bigger. This would be like 5, and now they're a little bit more apart, maybe like 4, right? And then 7, and then this would be 5, and so on and so on. So if you added all of these up, this one goes to say like 50, okay? It converges. Well, if this one's bigger and it's converging, then everything else would have to now converge as well, because this would be less than 50, right? So we'd also know it converges. It's a convergent series. So it's not telling us what the value is of the series. It's just saying, yeah, it's convergent. It's a quick way for us to tell. So let's look at our first one. If you look at this one, we can see that we have some general term here that is, it's a geometric, right? So if we look at just that general series, that general term, we can see that it really is basically this, which is this. And we know that that's sum from n equals 1 to infinity of 9/10 the power of n is convergent because r, which equals 9/10, is less than 1. So it's convergent, right? This is our absolute value of r. So now all we have to do is show that this one is bigger. So we write it, well, we know that's bigger, and we go back and we check it. Well, if you make the denominator bigger, you make the fraction smaller. So bigger denominator, smaller number, right? Which means this is true. And so that's the two conditions you have to meet, that A sub n is less than B sub n. So we've met that condition that it's less than, and that B sub n is convergent. And there we go. So therefore, the sum from n equals 1 to infinity of 9n over 10n plus 3 is convergent by comparison test. So we're comparing. So you must have this, number 1, and you must have this, number 2. You must be comparing it to another series that is convergent. All right, let's try another one now. Okay, so if we try this one, you can see that the ln of k over k would be comparable to 1 over k. And we know that series, this is divergent. And you can say that it's harmonic, or you can just use the p-series test, which is p is equal to 1, which is less than or equal to 1. And so we know it's divergent. So now we have to do is the reverse. So now you can notice our b sub n is at the bottom here. So like this is 3 and that would be 4. Same basic idea, 4 and 5. The top one is bigger. So if the bottom one is divergent, it's going off to infinity, then so is the one above it. It's also divergent. It's going off to infinity. Now also remember that they were dealing with positive terms here, so we're not worrying about them being negative or anything. These are just positive values. All right, so now we have to show that this one is smaller, that our b sub n is bigger. Okay, and so if you look at it, if we plug in 1, so if we check k equal to 1, that's where we're starting it at, right? Right? It's supposed to be a k, not an n. Okay, now we're good. We get ln of k, which is ln of 1 over 1. That's 0. And we know that's not going to work with 1 over 1, which is 1. So let's try k equals 2. ln of 2 over 2, and we get 1 over 2. And so that's not going to work as well. So this right now is not bigger, doesn't work. This is not bigger. But k equals 3, ln of 3. Remember, natural log has a base of e, which is 2.7. So we want that inside to be bigger. We know that is now bigger than 1 over 3. Oops, that's a 3 on the bottom. 1/3. So we know it's going to work. So all we have to do is put on there is k is greater than or equal to 3. And then now it's true. So we can say, therefore, the sum from k equals 1 to infinity of natural log of k over k is divergent by comparison test. And we know this is going to be true because the natural log now, once you start plugging in numbers 4, 5, 6, 7, 8, 9, 10, they're all going to be bigger than e. So this is always going to be bigger than 1 over and that number. So the top will always be bigger than 1 on the left side. So it works perfect. And so that's it. There's your comparison test. So if you want to show that it converges, you need to find something bigger that forces the other one down, is the way you want to look at it. That it's saying I converge, so you will converge as well. And with divergent, you want to think of it the reverse, is the b sub n is diverging. So he's saying I diverge, so you will also diverge, because he's pushing him up. So he's going off to infinity, so is this guy, right? Then he's going to say, I'm going off to infinity, so you got to follow with me because you're bigger than me. And that's it. There is your convergence test. Now, if these things don't work, right, say you're greater than or you're less than, it's not going to work, then we move on to the limit comparison test, which is coming up.